All right, good morning, class. Welcome back to Algebra 2, first and fourth periods. Today, our proverb is from chapter 8, verse 30. Then I, wisdom, was beside him as a master craftsman, and I was daily his delight, rejoicing always before him, rejoicing in his inhabited world. Just exciting to know that wisdom is available to us through his word. All right, today is Thursday, March the 9th. We are moving on to section 10.6. We are skipping 10.5. Section 10.6 is titled Sum and Difference Formulas. These formulas are going to be helpful, particularly with this first example I've got for us. It's from page 654. It's guided practice number 1. We are asked to find the sine value, the exact sine value of 105 degrees. If we go to our unit circle, moving around the circle, we go 60, 90, and then we skip to 120 degrees. So we'll note that 105 degrees does not appear on our circle. But if you can come up with two values that you can either add together or subtract and come up with 105, then we have formulas that will help us utilize those two values to come up with the sum of 105. A couple of things I know from our circle. We can take 45 and 60 and add up to and get 105. Do you see anything where you can do a difference? You could take 135 and subtract 30. So there are a couple of different ways, at least, maybe more. We can do 135 minus 30, or we can do 60 plus 45. This would require the difference formula for sine. This would require the sum formula for sine. So again, we're in section 10.6. There are sum and difference formulas found there on the front page. I chose for today for us to do the difference. So you have exposure to a difference formula. I do not know these, so I had to write it down myself. And I would not expect you to have them memorized, but I would expect for you to at least be able to find them. They're found on page 653. The sine of A minus B, so for us it'll be 135 minus 30. This will be A, this will be B. We're not going to use this one, although you get the exact same answer if you do. So you can do either a sum or a difference. I'm just doing the sum so you have exposure to it. The sine of A minus B is equivalent to the sine of A times cosine of B minus cosine, minus cosine of A times sine of B. You're going to say, well, where am I going to find those values? We're going to pull those from the unit circle. So I'm going to go ahead and fill in these. Again, A is 135 degrees, B is 30 degrees. So we're looking at the sine now of these differences. You cannot just subtract them, you're going to have to put them in this formula. So this says the sine of 135, which is A, times the cosine of B, which is 30. And then this is a big subtract sign. Then cosine of A, or cosine of 135 degrees, times sine of 30. Go back and double check, make sure you've written it down correctly, the formula. Make sure you filled it in correctly, and then you're going to have to go to your unit circle. We do not know anything about the sine of 105 degrees, but I do know that the sine of 105 is going to be equivalent to the difference of these products. So, sine of 135, that's cosine, that's sine. Sine of 135 is the square root of 2 over 2. And then cosine of 30 degrees. Cosine of 30 degrees is square root of 3 over 2, and this is a product. And we're going to have to subtract from it the cosine of 135, which is also square root of 2 over 2, except for it is negative. So I suggest parentheses, negative square root of 2 over 2, times sine of 30 degrees is 1/2. So if you remember how to multiply fractions, product of the numerator, product of the denominator. Square root of 2 times square root of 3 is the square root of 6. 2 times 2 is 4, minus, then we've got a negative square root of 2 times 1, which is a negative square root of 2 over 4. Subtracting a negative number is the same thing as adding the, adding the opposite. We have square root of 6 plus square root of 2 over 4. You may not simplify the 4s, 6s, and 2s. This is the final value. The only time you can reduce the 4 in the denominator is if there are coefficients in front of these two values. So the sine of 105 degrees is exactly square root of 6 plus square root of 2 over 4. You may also write it as square root of 2 plus square root of 6 over 4. And I think that's the way it works out if you actually do the sum formula. So hopefully that was helpful. Tangent will be next.